So we are going to talk about the imaginary number I. And I want us to look at this quadratic equation, x squared plus 1 equals 0. And this is when and how we are going to use imaginary numbers in this particular class. We are going to talk about solutions. And when I've asked you to find solutions for a quadratic or a cubic or a quartic, what am I asking you to find? When I say find the solutions to this problem, what am I asking you to find? X what? X-intercepts, okay? And those are the zeros of the functions. My x-intercepts are where my graph touches or crosses the x-axis. And I am still asking you to find those, but sometimes, and this is the graph of my x squared plus 1. Okay? This is the graph of x squared plus 1. Imaginary numbers, or imaginary solutions, they're also called complex, do not cross the x-axis. Okay? They are still solutions. They are still valuable. They just are not real solutions. They are complex and or imaginary solutions. And once we're talking about complex and or imaginary solutions, the graph does not cross the x-axis at that solution. That's what that means. Okay, that's what a complex number is. And complex and imaginary, there's just a small difference. So, the important thing that you need to know, this is the two important things that you really need to know. You need to know that I is the square root of -1. And almost as important is that you need to be aware that I squared is -1. And let's talk about why. Let's talk about why I squared is -1. If I have the square root of 2 and I multiply it times the square root of 2, okay, what I get there is the square root of 4. And what's the square root of 4? 2. Okay, so what I've done when I have I squared, I've done the square root of -1 times the square root of -1. Okay? So I squared is equal to -1. You don't multiply the -1 times the -1 and get +1. You don't get that. Okay? That's the part I'm talking about over there, about the multiplying. You've got to pull that I out. So I squared is -1, and that is super important. It's super important as we go through this. Okay, can I move off the screen? Good? Okay. Whoops. Okay, this is the definition of a complex number. Basically, what you need to know about the definition of a complex number is that it has a real component and an imaginary component. So if you've got 2 plus 3i, and that happens a lot, 2 plus 3i, this is a complex number. And the reason that it's a complex number is because this is real right here, because this is 2. We can put 2 on the number line. This is imaginary because it's being multiplied by I. So 3i is imaginary. A complex number has a real and it has an imaginary component. That's what makes it complex. Now, if I only end up with the 3i part, like if I don't have any real portion except for this coefficient, then that is what we call a pure imaginary number. Okay? That terminology is not necessary for you to have mastered. It is okay to not really have that down. I just want you to have that definition. Now, if we are talking about addition and subtraction, You can add and subtract complex numbers the same way that we add and subtract like terms. Your constants can be added together, and your i's can be added together. So you are going to do this the same way that you would combine like terms. Same way that you would combine like terms. Okay? So let's look at combining some of these. Here I've got 4 plus 7i plus 1 minus 6i. 4 plus 7i plus 1 minus 6i. Here, what I have to do is I have to ask myself, is there anything inside the parentheses that can be combined? Is there anything inside each set of parentheses that can be combined? No. Is there anything outside the parentheses that needs to be distributed? Okay, so the positive right here, is that what we're saying? Okay, and if that was a minus sign, I would agree with you. Okay, because this isn't a minus sign, you don't have to distribute it. But it is good that you're thinking that way because we are eventually going to have to distribute a negative. So I am able to rewrite this as 4 plus 7i plus 1 minus 6i. So now that I've eliminated my parentheses, I am going to combine like terms. So I have 4 and 1. So that gives me 5. Then I have 7i minus 6i. What is 7i minus 6i? Okay, I think I heard somebody say I. You can have one I or you can have I. Okay, so we treat that I the same way we would treat an X. Okay, same is true here. I've got 1 plus 2i plus 3 minus 2i. 1 plus 3 is 4. What happens here? What do I get? Okay. Is 0i the same thing as 0? It is, because 0 times anything, including I, is 0. So that's a real number. We're left with a real number. You only have to write the 4 in. Okay? Let's do the next one. Here, I've got to distribute some stuff. I've got to distribute some negatives. So I have 3i. I have to distribute this negative here. So I have plus 2 minus 3i. I need to distribute this negative. Okay, I'm going to combine like terms. 3i and negative 3i go away. What am I left with? Negative 5i. What happens to my 2 and my negative 2? Yep, they cancel out. I'm left with negative 5i. Okay, my next one, I only distribute here. Okay, my first 2 are added, so I just have 3 plus 2i plus 4 minus I minus 7 minus I. Okay, 3 plus 4, what's 3 plus 4? Okay, 3 plus 4 is 7, and then I've got minus 7. So what do I have? 0. 2i minus I minus I. What does that give me? Okay, so my answer to that one is 0. Can I go to the next screen? Okay, now multiplying complex numbers are very, very similar to multiplying real numbers. the thing that students forget to do all the time, this happens all the time, the number one thing that students forget is they do not simplify completely. So kind of put a star here. Be sure you simplify completely. Okay, be sure you simplify completely. Okay, now the first one is just a monomial times a binomial. So I'm going to take the 4 and multiply times the negative 2. Then I'm going to take the 4 and I'm going to multiply by 3i. So 4 times negative 2 is negative 8. 4 times 3i is 12i. Now this is not something that I can continue to simplify. Okay, I'm done there. This is complex. I have a real portion and I have my imaginary portion. Negative 8 and positive 12i can't be combined anymore. Part B, that's where we end up having trouble. This is a binomial times a binomial, so I am going to multiply these together using the FOIL method. So I have 2 times 4, which is 8. 2 times 3i, which is 6i. Negative I times 4, which is minus 4i. Negative I times 3i, which is negative 3i squared. Students almost always remember to simplify this right here. Okay? And they say 8 plus 2i minus 3i squared. And they stop. This is what I'm talking about when I say be sure you simplify completely. Be sure you simplify completely. This is where students get in trouble. What do we know about I squared? It's negative 1. So what we have to do is we have to deal with this I squared right here. So we get 8 plus 2i minus 3 times negative 1. What is negative 3 times negative 1? 3. So I have 8 plus 2i plus 3. And can I add the 8 and the 3 together? Yes. That is what students forget to do. That right there. They stop. This is where they stop. Don't stop. Keep going. I can't tell you how many times I write that on a test or a quiz. Keep going, keep going, keep going. I write that often. Okay? Now, if you're looking at the next one at part C, what do you notice about part C? It's the same, but what's it called? Difference of squares. Good. Difference of perfect squares. That's exactly what it is. Okay? So what's going to happen when I multiply these? What's going to happen to the middle? Let's find out. It's going to be a positive and a negative, and it's going to cancel. The middle two terms are going to cancel. But let's do it. Let's do it. I have 3 times 3 is 9. And I'm just foiling. 3 times negative 2 is negative 6i. 2i times 3 is positive 6i. 2i times negative 2i is negative 4i squared. Okay, what happens to negative 6i and positive 6i? They cancel. Okay, we expect that to happen because that's what difference of squares is. So then I have 9 minus 4. What do I know about I squared?
It's a negative 1.
It is a negative 1. So then I have 9 plus 4, which is 13. So this is difference of perfect squares. When I multiply difference of perfect squares together, what does my answer end up being? A real number. And that is super, super important. Math is cool. Okay. So that's what happens. When you multiply difference of perfect squares with complex numbers, you get a real number. And that, we're going to talk about why that is important with our next problem. Can I move off this screen? Can I move off the screen? No? Yes? Okay. Okay. In example 2C, that's the one that we just did, the product of two complex numbers can be a real number. This occurs with pairs of complex numbers of the form a plus bi and a minus bi. That's the difference of perfect squares. And those are called complex conjugates. So this is a squared minus b squared times -1. So we end up with a squared plus b squared. So this is why when I have x squared plus some number, that's why I can't factor that. Okay, so if I had x squared, plus 9 as a factor, and I set that equal to 0, what happens? How do I solve this if I set this equal to 0? I subtract 9, then I square root, and I end up with plus or minus the square root of -9. Then I have an I that I have to pull out. That is how I end up with imaginary numbers. Okay? And that's an imaginary number solution. And we're going to do that in a couple of minutes. What I want you to look at first is how we use complete conjugates to rationalize a denominator. Now, I was just teaching a pre-calculus class where I had to rationalize denominators. It was in trig, and my students got really mad at me because I took off points because they didn't rationalize their denominator. So then I went to all the calculus people that I knew on Facebook and said, hey, is it important for my students to know how to rationalize a denominator in trig? And that was like chaos. Calculus teachers feel very strongly about that on one end or the other. So I had a whole slew of them that said, yes, you've got to rationalize the denominator, and I had a whole slew of them that said, nah, it's not important. In this class, rationalizing the denominator is important. So that's what we're doing here. Okay? Do you see how in my original problem, this is my original problem right here. This is my original problem. Do you see how I have an I in the denominator? Do you see how I have an I in the denominator? Okay? That's actually not allowed. You've got to simplify it to the point that you get rid of that I in the denominator. You're not supposed to have an I in the denominator. Think back to probably Algebra 2, maybe a little bit of Algebra 1. Do you remember how if you had something that looked like that, what would you have to do to get rid of that square root of 2? Good. You'd have to do the square root of 2 over the square root of 2. And you'd end up with this. Okay, that's rationalizing the denominator. We're doing the same thing here, except we're doing it with the conjugate. So, I have 4 minus 2i. My conjugate is going to be 4 plus 2i. Okay, so I am going to multiply the top and the bottom by the same thing. When I multiply the top and the bottom by the same thing, what am I multiplying by? I'm not multiplying by the reciprocal. When I multiply the top and the bottom by the same thing, what am I actually multiplying by? 1. Good. 4 plus 2i over 4 plus 2i is 1. So I am multiplying this by 1. And if I multiply something by 1, then I'm keeping its value the same. Okay? So I'm going to FOIL the top. So I have 2 times 4. I'm going to rewrite this just so we can see it a little clearer. So I have 2 plus 3i over 4 minus 2i. That is my original problem right there. I am multiplying it times 4 plus 2i, and it is my denominator that drives that. Doesn't matter what's going on in my numerator. It is my denominator that drives what is right here. Okay? And since I multiply the bottom times this, what do I also do? Multiply the top. Okay? So I have 4 plus 3i. I'm going to FOIL the top, so 2 times 4 is 8. 2 times 3i is 6i. 3i times 4 is 12i. Yes. Oh my goodness, thank you. Thank you, thank you, thank you, thank you. It needs to be exactly the same. I know, I was too. Sorry about that. It's 4 plus 2i. Thank you. Okay? 2, let's try this again. 2 times 4 is 8. 2 times 2i is 4i. 3i times 4 is 12i. 3i times 2i is 6i squared. Okay? Then I'm going to do my denominator. 4, I'm sorry? They do not cancel out. In the denominator, they do. In the numerator, they do not. Okay? In our next step, we will combine 4i and 12i to get 16i. Okay? 4 times 4 is 16. 4 times 2i is 8i. Negative 2i times 4 is negative 8i, and that's what we want to happen. We want those to cancel out. Then I have negative 2i times positive 2i. That's negative 4i squared. Okay? These combine. So I have 8 plus 16i plus 6i squared over, these cancel, and I get 16 minus 4i squared. And I cannot tell you how many times students stop right here. Lots and lots of students stop. So I'm going to put a note. Don't stop. You are not done. Do not stop. Okay? I have 8 plus 16i plus 6 times what? What is I squared? Negative 1. Remember how I said that it's almost as important to understand that I squared is negative 1 as it is to understand that I is the square root of negative 1? This is why students stop. They don't simplify all the way. Then in the denominator, I have 16 minus 4 times negative 1. So I have 18 plus 16i minus 6 over 16 minus 4. Actually, that'll be plus 4. Negative 4 times negative 1 is plus 4. What is negative 6 and 18? Oh, thank you. Man. Okay. 8 and negative 6 is 2. Right? I better ask you guys. It's 2? Okay. 2 plus 16i. 16 plus 4 is 20. Now, this can be simplified even further. Do you see how this is a 2, this is a 16, and this is a 20? They can all be divided by 2, and it has to be all 3 of them. If it's not all 3 of them, it doesn't work. It's got to be all 3 of them. So this can be simplified to 1 plus 8i over 10. And I typically stop there. Like I typically don't go any further. However, some students will do 1 over 10 plus 4/5 I. Okay? And that's okay too. because you've given this 10 to both. 1 over 10. Then you've got 8 over 10. 8 over 10 simplifies to what? 4/5. Okay? Either of these is 100% correct. This you're going to get dinged because you didn't simplify completely, but you're not going to get dinged much. If you stop here, you're going to get dinged a lot more. Okay? So you definitely want to keep going at this point right here. Okay? Questions about that? Okay, can I go to the next screen? Okay. So I'm going to kind of do things in a different order, just so that we can, so it makes a little bit more sense to our brain. Okay. The first thing that I want to talk about is multiples of I. Multiples of I. Okay? So, I want you to think about if I've got -1 and I do that to the first power. What's -1 to the first power? Not the square root of -1, just -1.
1.
How about -1? That's what it is. -1 to the first power is -1. I know. I kind of switched gears on you. What's -1 squared? Good. What is? That is 1. You're right. -1 squared is 1. What's -1 to the third power?
-1.
Yes. What's -1 to the fourth power?
1.
Good. -1 to the fifth power?
-1.
Do you see a pattern? I do. Okay. How does it rotate through?
Every even is 1, every odd is negative.
Good. If you raise -1 to an even power, you get +1. If you raise -1 to an odd power, what do you get? -1. So we are going through a cycle of -1, 1, -1, 1, -1, 1. Okay? If I said to you, what's -1 to the 11th power? What would it be? -1, because 11 is negative. 11 is odd. If I asked you what -1 to the 100th power was, could you tell me? It's 1 because 100 is even. Now, we have a similar cycle for I. Okay, so let's talk about that. We know that I is the square root of -1, and we just think about that as I. We always think about that as I. Okay? We also know that the square root, or that I squared, is -1. Now, if I've got I to the third, could I say that I squared times I is the same thing as I to the third? Could I say that? Now think about exponent properties. When your base is the same, what do you do with the exponents? You add them. So is I squared times I the same thing as I to the third? Yes, it is. What's I squared? Good. Okay? So then I have -1 times I, and that's -I. Okay? Is I to the fourth the same thing as I squared times I squared? Yes. What's I squared? Okay? Now, is I to the fifth the same thing as I to the fourth times I? Yes. So then I have 1 times I, or just I. Is I to the sixth the same thing as I to the fourth times I squared? So that is 1 times I squared, which is is I to the 7th the same thing as I to the 4th times I to the 3rd? So that simplifies to negative I. What's I to the 8th?
1.
Good. Good. So we also have a cycle here, except instead of having 2 things that it rotates back and forth, we have 4. So I is I squared is negative 1, I to the 3rd is negative I, and I to the 4th is 1. That's the cycle of I that we go through. Okay? So if I've got I to the 30th, what is the closest multiple of 4 to I to the 30th? What's the closest multiple of 4? Say it. That's okay. 28. Okay? So how many do I have left over?
2.
So I have I to the 28th, because that's a multiple of 4, times I squared. I can mark this out completely because what does that simplify to? A 1. I to the 28th is a multiple of 4. Okay? I to the 28th is a multiple of 4. So I am left with positive 1. And we know what I squared is. What's I squared? Negative 1. Question over there? Did I mess something up? No? Okay. Sometimes I mess stuff up. And I leave it to you guys to tell me. Okay. I to the 27th. What's the closest multiple of 4? 24. So I have I to the 24th. And how many do I have left over?
3.
I to the 24th. We're done. It's a multiple of 4. So what is it? 1. I to the 3rd is? Okay. What about I to the 40th? Not, nope, it's not I.
It's 1.
It's 1. 40 is a multiple of 4. So any multiple of 4, we're going to get back to 1. Any multiple of 4, we get back to 1. So we factor out all of those multiples of 4, and we only deal with what's left over. Yes, and then Carol.
So the only way it's I is if it's not a multiple.
The only way it's I is if it's not a multiple of 4 and you've got 1 left over. Yes. So like I to the 5th is I. I to the 11th is I. No, I to the 9th, I'm sorry. I to the 9th is I. I to the 17th is I. Kiera?
So if it's raised to an even, you're gonna get 1 or negative?
Yes, if it's that's a good way to look at it. If it's raised to an even number, you're either going to get negative 1 or you're going to get 1. And if it's raised to an odd, you're either going to get I or negative I. That's a great way to look at it.
So
I is not 1. I is the square root of negative 1, and that's just the first thing. That's the first in the cycle. So we have I, negative 1, negative I, positive 1. And you can write it out. I mean, if you want to write it out 40 times, you can.
Oh gosh.
You can. I'm just saying you can. You don't have to. Okay. Can I go to the next screen? Okay. Here we go. This is something that I just want you to be exposed to before we start solving a bunch of stuff. And we are going to start solving a bunch of stuff in a few minutes. What you need to know, the take-home point for these types of questions right here. You must take I out first. Okay? You must take I out first. Look at my very first one. I've got the square root of negative 5 times the square root of negative 2. You have to take that I out before you multiply the 5 and the 2 together. Okay? The first thing that you have to do is you have to take that I out. So I am going to have I on the square root of 5 times I on the square root of 2. What's I times I? What's the square root of 5 times the square root of 2? It's a square root of 10. It's not a perfect square, so you just are left with square root of 10. Okay? What is I squared? -1. So this is my final answer. Some students will write it as negative square root of 10, and that's fine also. Okay? You must take the I out first. Okay? Start dealing with that first. Okay? Here, I'm going to deal with the I. I'm going to pull that I out. So I'm going to have I on the square root of 25 times I on the square root of 16. Now, you could do this one of two ways. I'm going to go ahead and do my I times my I, because that's I squared. Can I take the square root of 25? What is it? Good. Can I take the square root of 16? Okay, so I get I squared times 20. What's I? Good, so I have -1 times 20. So my final answer here is -20. Now, some students will choose at this step right here to multiply 25 times 16. Then they would get the square root of 400. The square root of 400 is 20. So you would have I squared times the square root of 400. So you have I squared times 20, which is still -20. If you can simplify things, I would simplify them because you're dealing with smaller numbers. Would you rather deal with the square root of 25 and the square root of 16, or would you rather deal with the square root of 400? Okay? So it's not wrong to do it that way. I just want you to be aware of that. Okay. Again, go ahead and get in that habit of taking that I out. Can I take the square root of 49? Good. So then I have 7I. It's not I squared, so I can't do anything with that. Okay? Now, square root of 3 times square root of 3. We don't have any I in there. So that's just 3. Now, square root of -3 is imaginary. Negative square root of 3 is real. What's the difference between those two? The negatives on the inside versus the negative on the outside. Okay, sometimes students get that confused. Okay. I'm going to go backwards about 4 or 5 slides. Can I move off this one? No. Which one?
Square root of 9. So why are you taking the negative out? Outside of the square root?
Are you talking about square root of 3 times square root of 3?
No, it's the imaginary.
Oh, what I'm telling you is that these are two totally different numbers. Okay? If you've got the square root of -3, that is an imaginary number. It does not cross the x-axis. Okay? I'm wanting you to see that that is different than negative square root of 3. Negative square root of 3 does cross the x-axis, and it is a real solution. It's an irrational solution, but it is real. These are two different things. I just want you to realize that they're two different things. Good question. Okay, can I move back? Okay. Okay, this is what I want to talk about. In a complex number system, every nth degree polynomial has exactly n zeros. Now, you have to account for multiplicity, and you have to account for real and complex. But if you've got x to the third, how many solutions should you find? 3. If I have x to the fifth, how many solutions? If I have x to the seventh, which Lord help us if we have x to the 7th. How many solutions? 7. Okay? That's what this is saying. That's what this is saying. Now you have to account for multiplicity. Sometimes you've got a 0 that shows up more than once. And if you remember on your quiz, number 6, what happened? Because it bumped. What did that tell you about that solution? When it hits my x-axis and goes the other direction, what does that tell you my multiplicity is? Even. And in that case, it happened twice. So, if I have f of x equals x minus 2, that has exactly 1 0. It crosses the x-axis exactly 1 time. Okay? Because this is raised to the first power. So if I do 0 equals x minus 2, what is my solution? X equals positive 2. Now, for this one, x squared minus 6x plus 9, I'm going to have 2 solutions. Okay, this can be factored. This can be factored to x minus 3 times x minus 3. So my solution to this is x equals 3, but how many times does that occur? Twice. So my 0 is x equals 3 with a multiplicity of what? 2. Okay, and both of those are real. I have 2 real solutions. For my first one, I had 1 real solution. Okay? This is not going to cross the x-axis. It's going to bump, and it's going to bounce at the x-axis because I have a multiplicity of 2. Okay? Can I go to the next one? The third degree polynomial function. How many zeros am I looking for? 3. I'm looking for 3 zeros. They may be real. They may be complex. They may have a multiplicity. But I'm looking for 3 because my degree is 3. So I'm going to set it equal to 0. I have an GCF I can factor out. Okay? I have a GCF I can factor out. I'm going to set each one equal to 0. Okay? When I do x squared, I get negative 4. When I take the square root of both sides, I have to add my plus or minus. Okay? I have to add my plus or minus. Remember, if I've got the square root, or if I got x squared equals 16, if x squared equals 16, immediately what do we know x is? X, it's 4. What do we forget that x can also be? Negative 4. So we've got to have that plus or minus. So I have plus or minus the square root of negative 4. I pull out my I. So I have plus or minus I on the square root of 4. What's the square root of 4? 2. So my answer to this is x equals plus or minus 2i. So my zeros are 0, positive 2i, and negative 2i. When I have this right here, don't forget that's 2 different solutions. That's 2 different solutions. Yes?
Okay, I kind of got confused.
That's okay.
What if it's like a difference of squares instead of the sum of squares?
Okay, so if it is, so you're asking instead of x squared plus 4, what if we had x squared minus 4?
Yeah.
That can be factored to x plus 2 and x minus 2. And those are both real solutions.
Okay, so we only did it because it was the sum of.
We only did it because it was sum. Now, if you just went ahead, so if you had if you had this right here and you set it equal to 0, if you weren't thinking that it was difference of perfect squares, I would still end up with x squared equals positive 4. Okay? So then, as long as I take the plus and minus of that, I'm in good shape. But I'm not dealing with something that's complex because I don't have the negative in there. But typically, I encourage you to solve x squared minus 4 as difference of perfect squares. But if you don't, you're still okay. You're still okay. That was a good question. Okay. Now to put it all together. Here we go. This is why we've done everything that we've done in this chapter. I've got 3 problems to show you, hopefully in the next 15 minutes. If I don't, I'll do the last one on Thursday. But this is putting everything from this chapter together. I want to solve this. I've got 3x squared minus 2x plus 5. 3x squared minus 2x plus 5. This is a quadratic, and this cannot be factored. I know it cannot be factored because I have a positive sum. My sum is positive 15. 3 times 5 is positive 15. When I have a positive sum, I've got to have 2 negatives or I've got to have 2 positives. Okay? My sum is negative 2. There are no 2 numbers multiplied together that give me positive 15 and added together give me negative 2. So I have a choice to make. Okay? I can solve by completing the square. Or I can do the quadratic formula. Now, I'm lazy. Is it D-I-C or T-I-C? Quadratic. D-I-C?
T-I-C.
Oh, my goodness. Is that right, you think?
Yeah.
Okay, thank you. Okay, now, I'm lazy. The only time I do completing the square is when this right here is a 1, and that's even. That's when I use the completing the square. Because if I use completing the square in this, I'm going to get so many fractions, it's going to make my head hurt, and you guys are going to call me all sorts of bad names. Okay? So, we are not going to use completing the square. We are going to use the quadratic formula. You will be given the quadratic formula. You don't have to have it memorized. The quadratic formula is negative b plus or minus the square root of b squared minus 4ac all over 2a. Where do I get the a, b, and c from? 3, negative 2, and 5. They are the coefficients. So it's a x squared plus bx plus c equals 0. So in this situation right here, my a is 3, my b is negative 2, my c is 5. Okay? So I have negative b plus or minus b squared minus 4 times a times c. And all of that is over 2 times a. Now what I tried to do is I tried to plug in the numbers in red. Okay? So the negative 2 is my b value. Okay? The negatives throw students off. This right here is where it throws them off the most. That negative right there. What is negative 2 squared? Positive 4. If you make a mistake, it's right there. And students will turn -2 squared into -4. And any negative number that you've got for B, when you square it, you're going to get a positive. Okay? So be careful of that. So that's why I do it in different color, just to try to help you see the difference between what I'm plugging in and what's part of the problem. Okay? So now I've got positive B plus or minus, oh dear, okay, plus or minus 4 minus 4 times 3 times 5. -60. Oh, no. Got to find the right angle. I got to get that. I guess I need a new tip. Can you buy just a tip to an Apple Pencil? Okay, good. Okay. So I have 2 plus or minus the square root of 4 minus 60. So 2 plus or minus the square root of -56 over 6. Don't stop. This is where students want to stop. You're not done. Okay, the first thing that I hope you'll do is take out your I. Okay, we've got a -56 in there. So that's the first thing I'm going to do. I've got 2 plus or minus I on the square root of 56 over 6. Now, do you see up on the board how I have perfect squares written out? Okay, 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16. What I want to do when I look at that 56 is I want to find a perfect square in that 56. Okay, so I'm going to have 2 plus or minus I on the square root of 4 times 14. The reason I picked 4 times 14 is because 4 is perfect. Now, I know that 8 times 7 is 56. That gets me nowhere because 8 is not perfect. I've got to have a perfect square factor because now I can take the square root of 4. What is the square root of 4? Okay, so I have 2 plus or minus 2i on the square root of 14 over 6. Now again, I have a 2, I have a 2, and I have a 6. Okay? Can I take a 2 out of all those? Okay, it does not matter what's here. I'm not dealing with that 14 because it's inside. I'm only dealing with those numbers on the outside. 2 goes into 2 one time. 2 goes into 2 one time. 2 goes into 6 3 times. 1 plus or minus I on the square root of 14 over 3. Some students, and you don't have to do this, some students will rewrite that as 1/3 plus or minus the square root of 14 over 3i. Okay? Either one of those is correct. I prefer the top, but that's just my brain. Okay? This right here is why we're doing everything. This is the culminating. This is the final. Oh my gosh. That was my fault. That was my fault. Okay. Now, what this is telling me right here, and we talked about this some on Tuesday, is we are going to look at our quotient right here. You see that a to the 0? That means that's a constant. We are going to look at factors of that to get started. One of the questions that I got over the weekend was, how do I get started? Alicia, I'm doing all these problems, and I don't know where to get started. Where do I get started? Okay? And where did I tell you to get started? On a problem like this, I can't factor it. Where do I get started? What do I look at? Okay, so you can't do factor. So I'm going to use synthetic division. I'm definitely going to use synthetic division. So I'm going to have these coefficients. But I need to know, what am I going to put in that box? What do I put in my box? Do I just start randomly picking numbers?
1.
Why 1?
Because
It's reasonable to start with 1, but why? Okay, look at that negative 6. Okay, is 1 a factor of negative 6?
sure is.
It sure is. What else is a factor of negative 6?
3.
Okay,
2.
good. And what else?
6.
6. Okay? When you are doing synthetic division and you don't know where to start, you pick some of those numbers. Should I pick 5?
No.
No, because it's not a factor of 6. Should I pick 7?
No.
4?
No.
No. You do not pick any number that's not a factor of that constant right there. Okay? That's why I picked 1. And I don't know if 1 is going to be a factor. I don't know if it's going to work or not, but we're going to try. Okay, so I'm going to pull down this 1. 1 times 1 is 1. Apparently I changed colors mid. Don't know how I did that. Okay, 1 times 0 is 0. 1 times 1 is 1. 1 times negative 2. Okay, so I got a remainder. So what does that tell me?
That you used the wrong number.
I used the wrong number. This is not a solution. X minus 1 is not a factor. Okay, so now I'm going to use the next one.
Negative 2.
I'm actually going to use negative 1.
Oh, negative 1.
I'm going to use negative 1 because I like to use those small numbers. I'm going to pull down my 1. Negative 1 times 1 is negative 1. Negative 1 plus negative 1 is negative 2. Negative 1 times negative 2 is 2. 1 times 2, 1 plus 2 is 3. Negative 1 times 3 is negative 3. Things are looking good.
There we go.
Good, that's what I want. What this tells me, negative 1 is a solution. If negative 1 is a solution, what's its factor?
X plus 1.
X plus 1. Okay, now I've got x squared minus, nope, I don't have x squared. What do I have? X to the third.
Oh,
Minus 2x squared plus 3x. Okay, this can be factored. Let's do it. Let's factor it. How are we going to factor it?
We're going to try 1.
Nope, we're going to factor by grouping. Is what I'm going to do.
Oh, because it's 1 and a...
Yeah. I can factor this by grouping. If I couldn't factor it by grouping, you certainly could do synthetic division. Every once in a while, I get a student that prefers synthetic division over factoring. It doesn't happen that often, but every once in a while I do. And so you certainly could use synthetic division. Positive 1, I mean, you don't need to use any of the numbers that we already know doesn't work. Okay? But I'm gonna factor. So I've got x squared times x minus 2. Then I've got plus 3 times x minus 2. So I have x squared plus 3 and x minus 2. Okay, that x minus 2, I stick that equal to 0, and what am I going to get as a solution? 2. Okay, if 2 is a solution, x minus 2 is a factor. Those are my only rational answers. Negative 1 and 2 are my only rational answers. I am now going to deal with this x squared plus 3. If I've got x squared plus 3, is that the same thing as x squared equals negative 3? Yes. So now I've got x equals plus or minus the square root of negative 3. What do I have to pull out? And then I'm done. I. So I have plus or minus I, and I'm running out of room, on the square root of 3. These are solutions. So I have I on the square root of 3, and I have negative I on the square root of 3. Okay? So I have 2 rational and 2 imaginary solutions. Does that fit with my x to the 4th? Yes. Okay, here's my, here's the other thing that you can do. And I know that not everybody has a graphing calculator, so I will take that into account when I write the test. One of the things that you can do is you can graph this solution right here. And you can see where it crosses. You see how it crosses at 2 right here? That means I can put 2 in my box for synthetic division. Here, you see how it crosses at -1? That means I can put -1 in my box for synthetic division. So if you get stuck on some of those large constants on your homework, graph it. Graph it. And you're going to be able to identify what to start with by where it crosses the x-axis. Okay? I will see you on Thursday. I'm sorry? Do you have it in front of you? I'm almost certain it's the odds for the complex. And I know it's on. If you click on one, you'll see it. And that's close. So this is
Should have. Good, huh?